Good morning. I'm just going to get rid of a little bit down there that I had still left over from my practice run. Okay, this is example 3 using the recurrence relationship. So we're going to invest $45,000 at 6.3% per annum, and it's compounding yearly. So we're asked to find what the investment worth is at the investment is worth at the end of 8 years, and how much interest was earned in the 5th year. Now that's the tricky bit. Means I can't use compound interest, so I'm going to use that the geometric series idea of the recurrence relations. So I know that let me get my pen back. A to the 0 is going to be equal to 45,000. And I know that my I is going to be equal to 0.063. And it's compounding yearly, so that makes life very simple. I don't have to worry about that. My compounding periods are n, which is 8, but that's not important, only in our formula. So I know that a to the n plus 1 is equal to r a to the n. The r is 1 plus I. So a to the n plus 1 is equal to 1 plus 0.063 times a to the n. Simplify that up a little bit. A to the 1 plus 1 is equal to 1.063 a to the n. Now let's start this rolling, because we know that a to the 0 is equal to 45,000. So therefore, if I substitute a to the 0 back in here, I'll find a to the 1. So a1, because 0 plus 1 is 1, a to the 1 is equal to 1.063 times 45,000, and that's going to give me 47,835. So that now becomes my value for A1. So to find A2, it's going to be 1.063 times this new A1 value. So that's 47,835, and that gives me an answer of $50,848.60. We keep doing this. I did say it was going to be repetitive. 1.0, I didn't say here. I did in my earlier video that I had to delete. All right, so we keep going here, and I don't know if you find this easier than simple interest, possibly because we're just doing the same thing over and over again. So let's A3, this is going to be equal to $54,052.06. We do need to do this method, as boring as it might be, because it asks for what the interest is going to be in the 5th year, and we're nearly there. We do have to find the 8th year as well. 8 to the 4, the value is 54,052.06. Put that into the calculator, and I get $57,457.34. Obviously, in real life, this would be an excellent spreadsheet. Or you could lay it down in a table. That would also be a valid method for laying this out. Putting 2 equals on a page is not really the best idea. I'm up to a to the 5th, and a to the 5th is $61,077.16. A to the 6th, it's like getting to the bottom of the board. So that's going to be equal to $64,925.02. Just going to slide up a bit so we can see that. a to the 7, we'll finish this off, 1.063 times 64,925.02 gives me, I've got my dollar sign as everyone else, 69,015 cents and $69,015.29. And finally, we get there. A to the 8 is equal to 1.063 times 69, so 5.29 gives me a grand total after 8 years of $73,363.26. All right, so that's the answer to A, which is what was the value worth after the 8 years. We have to answer B, which is how much interest was earned in the 5th year. So for actual B, interest in the 5th year. Okay, so now I need to go back and have a look at the 4th and 5th year. So I'm interested in these two here, these two values. That's my 5th year, isn't it, coming across here? Yes, so I want this one and I want this one, because it's the 5th year minus the 4th year to find out how much was actually earned in that 5th year. So just going back to blue pen, the interest is equal to A5 minus A4. It's just sliding up. A5 is 61,077.16 minus the 57,457.34 earned in that 4th year. And that, when I put it into my calculator, equals a grand total of $3,619.81. So therefore the interest earned in the 5th year was, with my dollar sign, $3,619.81. Okay, that's how we roll.